So I'm actually going to start with section 7.5 and then come back to the material in section 7.4. So consider a cylinder that is sealed by a piston at one end, and it's airtight. And let's say that we've got some mass sitting up here. And if we go ahead and place a flame down here and get this nice and hot, what will happen is this piston head will lift up and lift this weight up and do work. However, we haven't actually applied a force to the system. So how is it that work is being done by this sealed cylinder? It turns out that we have to make an addition to our energy principle, that the energy of the system is changed not only by work, but by adding heat to the system. We're going to call heat Q. Don't get this confused with the charge Q. Q is heat, or another type of energy transfer. So we have to make this addition to the energy principle. We can also add other types of energy transfers on here as well, which the book talks about a little bit. But for our purposes, we're now including the fact that work done by a force changes the system, but also adding heat to the system. Q and W, again, are still measured in joules, or whatever units of energy you want to use. So what this kind of implies to us is that temperature is related to energy. So what we need to do is consider the internal energy of a system. Let's imagine that we have here a block, and this block has some gravitational potential energy. Let's say it's some distance off the table. We've chosen this to be y equals 0, and this block is moving with some velocity v. So we would call the external energy of the block the kinetic energy associated with this velocity. The external gravitational potential energy would then just be the gravitational potential energy associated with this distance above our y equals 0. But if we were to go ahead and zoom in closer on this block, we would see that there's a whole bunch of things going on in there. And if we're just using our model of the ball and spring for atoms, if we zoom in on a little bit of this block, we'd see that we have all of these atoms in here consisting of these balls and springs moving around. And the motion of these individual atoms is not accounted for in our external energy. So we have to include some internal energy. And the internal energy is going to consist of things like the vibrational motion of these atoms, as well as any potential rotational motion. There's also energy associated with these bonds. Now, these springs we're just using as a stand-in for the molecular bonds, but there is what we could call chemical energy or bonding energy between the atoms. And we also have the fact that the atoms can be moving. Now, in the solid, they're not moving around other than vibrationally. But if we have a gas where they're free to move around, we do have to consider their translational motion. And the temperature is related to that translational motion. So we need to consider that in our energy. Just to be clear, the external energy is basically the stuff that's happening on the macroscopic scale. It's the large scale stuff of the object itself, whereas the internal energy is what we would see if we could go ahead and zoom in on the object itself. Now, we need to define a quantity of the specific heat, and this is relating how the temperature changes as we go ahead and change the energy of the system, in particular the thermal energy of the system. So C, our quantity we call the specific heat, this tells us how much energy we have to add to every single chunk of mass to change the temperature. Now, we can rewrite this equation as delta E thermal is equal to mc delta T. So if we go ahead and add a bunch of energy, then based on how much mass we have and the specific heat of a particular item, then we can figure out what that change in temperature is. Typically, the units of C are measured in terms of joules per gram per Kelvin. There are other possibilities, but for our purposes, typically joules per gram per Kelvin. You'll also sometimes see this written as joules per Kelvin per gram. That's really just the same thing as this. So make sure that you understand what the specific heat is, what it tells us, and how to use it. A few other things that you really want to pay attention to in this section are the signs of Q, the signs of that heat energy transfer. When is Q positive and when is it negative? You also want to look at the meaning of the word heat. It has very specific meaning in terms of physics. And then finally, look and see whether or not Q and the thermal energy are the same thing. The book actually does go into this in a little bit of detail, so take a look at that.